my dudes and my dudes. In the previous part of this video series, we did a research market and bought our PC components at the best possible price, always of course within the range of our local market limits. Now it's time to renew and recondition some of these parts, and the reason behind this is that even though there are ways to ensure that if you buy a product from the web that doesn't correspond to the condition or the description of the seller's listing, you will get eventually a refund. Still, as a buyer, you don't know the remaining lifespan of the used components. You can only estimate it according product's launch year, seller's usage description and images, but other than that, you can't be 100% that the listed component will work flawlessly. You can always inspect the product and test it on site if it is a pickup cell, otherwise you have to take a leap of faith and test it after you have already paid for it. Additionally, you can prolong your used component's lifespan and improve its performance by reconditioning and renewing it. How can you achieve this? Is what this video talks about. Keep in mind that this phase is not required if you want to build a computer. If you think that all this stuff are too advanced for you, then you can jump in to the building and installation phase of this video series. Otherwise, stay a while and listen. First, we need to gather up all the needed tools we talked about in the first video of this tutorial series. For more information, click the link on the right corner or check out the description below. The computer parts that we're going to renew are the motherboard, the processor, the graphics card and the power supply unit. Let's take a closer look at PC parts one by one. We begin with the motherboard. No, I said the motherboard with D at the end. The refurbish process begins by checking the CMOS CR2032 lithium coin cell battery with a multimeter. To remove the battery, use the tip of a screwdriver to push in the pin that holds the battery in place and then pull the battery out. The acceptable voltage value is between 3.2 to 3 volts. Lower than this threshold indicates that it's time to restore it with a new one. Place the battery back to the slot with the positive side looking up. Now it's time to check out the Southbridge chipset. To remove chipset's heatsink, look at the bottom side of the motherboard and find the two V-shaped plastic pins that hold the heatsink in place. With the help of a needle nose plier, gently squeeze the pins that usually are spring-loaded and automatically snap through the board. If they don't, then push the pins in with your fingers. After this, the heatsink falls off and exposes the chipset's die. If the heatsink remains upon the chipset, then you can use a hairdryer to warm up the old thermal paste that lies between, aiming at the back of the motherboard, until you can gently twist right and left the heatsink and then pull it up. Then remove the thermal paste with a napkin, applying a small amount of isopropyl alcohol upon it. Do the same to the bottom of the heatsink as well. Now it's time to apply thermal paste to the top of the chipset and put the heatsink back to its place by aligning the heatsink over the chipset so that the mounting holes are properly positioned and pressed down until the two clips pushed through the board. Remove any trace of dust and any small bits of corrosion with a brush soaked with alcohol, gently brushing the motherboard's surface on both front and back side. Store the motherboard inside the ESD bag to protect it from the dust and the undesired electrical discharges. Now, let's move on the processor, the PC component that if you don't have it, your computer will be definitely brainless. The purpose of reconditioning the Intel i5-3470 is to replace the old dry thermal paste that lies between the processor's die, or with more simple words, the chipset of the CPU, and the integrated heat spreader, or IHS, meaning the metal cover that protects the CPU's chipset. This will improve the functional quality and the workload temperatures of the CPU. First, we need to separate the die from the IHS. To do so, we need a tool called delid toolkit. Thus, we call the whole task delid process. You have to buy also the liquid metal thermal material that is going to be applied upon the die and a high temperature silicon sealant to seal the chipset with the IHS. Having all this makes the rest of the job considerably easier. First, you align the processor inside the delid tool, using as a guide the CPU's golden triangle corner. Then, slot in the slider, attach it to the screw, and use the hex wrench to turn the screw until the IHS pops off. Now remove the soft plastic, and then, with the use of alcohol and a napkin, the old thermal paste from the die, and then remove also the silicone adhesive from the edges, being careful not to scratch or damage the chipset or the electronic components contacts around it. Do the same to the IHS and remove the paste and the silicone without scratching the metal. Now it's time to apply the liquid metal upon the chipset using an earbud, applying a very small amount into the die and then spread the material equally upon the surface of the die. Do the same to the IHS using as marker the stain from the old thermal paste. Apply and spread thin around the PCB and the IHS a small amount of silicone sealant, following as mark again the traces of the old adhesive. After you finish, place the processor inside the delid tool like you did before, without touching the liquid metal or the silicone, and use the press tool to pin down the IHS for at least 3 hours. After that, the CPU is resealed and ready to go. Just for the sake of science, I did a before and after stress test under extreme workload conditions running the Prime 95, demonstrating an average difference of 9 to 10 degrees Celsius in all 4 cores. This means that we just prolong the CPU's lifespan and working stability with this delicate but easy to master procedure. It is petite, it fits everywhere, it doesn't need much to be happy, and this is the graphics card we're talking about. The GTX 750 Ti. The renewing process begins with the unbolting of the 3 backplate screws and the 4 heatsink screws at the bottom of the PCB. Then, carefully separating the PCB from the cooling system, unplugging the fan power cable, removing the shroud of the cooling system to expose the bottom side of the heatsink where the GPU chipset makes contact. After that, I had to remove the resides of the old thermal paste with the help of a paper napkin and alcohol. Next, I pulled out the fan, unscrewing the 3 small screws lying at the base of the fan behind the blades, wiped out any trace of dust remaining at the blades and the heatsink, and I applied new thermal paste at the top of the GPU chipset. It is important, so do not forget that. To put everything back together, just follow backwards the steps I took to disassemble the graphics card. And voila! Our GTX 550 Ti is ready to kick some.
I have come here to chew bubblegum and kick ass.
Talking about kick butts, if you like this video, then kick it out of the subscription button and don't forget the button beside it, with the bell sign, so to be notified first for every new and fresh follow-up video. Now, it's time for our power supply unit. The only way to bring into life our PC components is through a power supply unit. Without it, all efforts to build our budget gaming computer will be futile. Moreover, the quality of the feeding energy provided by the power supply unit into components is crucial, since the lower the quality of the electrical signals running into the PC, the more unstable our system will be. Since very few people have the tools and the knowledge to do quality tests on a power supply unit, an ordinary PC builder has as only way to examine the condition inside the power supply by looking for bad electronic components, such as like bulged capacitors, burnt resistors, weird discoloration of the PCB, rusty connectors, and so on. It helps also if we remove any kind of dust resides inside the power supply. Having knowledge of PSU's previous usage, it's one more way to estimate the remaining lifespan and good working condition of the power supply. For example, our build used the Antec VP 550P, a 550 watt power supply that was installed for a couple of years into a workstation, and after it being replaced by a different PSU, it been stored waiting the moment to serve again. Antec is a well-known brand name in the market of power supplies, and our model, even though it doesn't feature top-notch painting job, LED lighting and other glamorous stuff, it offers reliable reviews and solid and decent performance, with good voltage regulation on all rails, outstanding ripple noise suppression, and high tolerance to high temperatures. Considering the low requirements of the rest of our components, Antec VP 550P fits right into the picture, guaranteeing a smooth operational PC system. Of course, we couldn't leave our old apprentice like that without the classic Refurbish treat, but before this, a fair warning. Power supplies carry inside lethal electrical current, even if they are for weeks powered off and detached from the socket wall. If you don't know the basics of electronics, it is better to not attempt the following Refurbish guide. Said that, we begin by removing the metal shroud, usually unscrewing 4 plus 2 screws at the top and bottom side plus 2 on the back of the box. Then we unbolting the 4 fan screws. You can unclip the fan from the PCB or leave it connected. It doesn't make big difference to the next stage, that is to blow out all the dust residing inside the PSU's chassis and remove any dust might lay upon the blades of the fan with the use of a brush or something similar. After you've done this, it's time to put everything back together. Mind to place the fan as it was, in our case with the side that takes the air inside looking at the top. After done with the PSU, there was one more thing to do. All I needed, it was a paint spray bottle, a self-adhesive A4 size transparent vinyl sheet, an inkjet printer, a bit of data research, and a lot of patience. The final result was rewarding, knowing that the whole task gave an extra artistic touch to the final build. And with that, we reached the end of phase 2 of this video series. Next phase is where we're building our gaming rig and installing the operating system. But more for this next week. Until then, my dudes, my dudes, respect yourselves and enjoy lives, dudeness and computers. The dude abides.
I'm just good at caring too much. I'm just good at caring too much. Is it too much to ask that you be all mine? I never was good at sharing. I'm just good at caring too much.
Alright.